Hi guys, Miss O'Connell here. So it's now 10:40, so it's been about 10 minutes since the session started. So I'm going to record my live exam review for you. So here it goes. So I'm going to present my screen in the Google Meet in case somebody is joining. Okay, so I'm going to show you here the agenda and the exam review. So I went ahead and completed most of the typing to save us some time. This document is shared out with you in Classroom, or it will be once the recording and the session is over. So I'm just going to take a few minutes to first talk about the actual exam and the exam day. Okay, so before your exam day, there's a checklist that you need to complete and print out. And that's linked in the agenda. So your checklist, you need to know your 8-character AP ID, and you need to handwrite it down on this piece of paper. So I suggest that you print this out at home if you have a printer. If not, just write down the information you need on a piece of paper. It's really that simple, okay? You don't need a printer. You need your 8-digit AP ID. You need to know, obviously, your exam date, the check-in time, and the local start time. Exam, I know you're so lucky. So your exam date is Monday, May 11th. You must check into the exam 30 minutes before the exam. So basically, all of your materials need to be ready an hour before the exam starts. During the 30-minute check-in period, you're filling out paperwork. So you won't have time to get your materials together. You need to have them ready before that 30-minute check-in. So the actual start time of your exam, which if you log in at your start time, you are SOL, okay? Honestly, you really need to get there 30 minutes before. So your exam's gonna start at noon, 12 p.m. The check-in time is 11:30 a.m. You need to have your stuff together before then. Okay, so I know that some of us have a history of being late to things or doing things late or being in our own worlds. So what I want you to do right now is take out your cell phone. Yes, take out your cell phone. And you're gonna set a reminder, okay, in your calendar on your phone for Monday, May 11th at 10, 10:30, 11, and 11:30 a.m. So that if you weren't awake and out of bed by 10 a.m., you have a series of alarms to make you wake up. It's important that you eat something, that all your materials are ready, and that you're on the computer at 11:29 a.m., ready to check in and begin the test. Okay? So make an alarm right now. Pause the video, make an alarm. We're going to quickly go through this checklist, which again is available to you in that agenda. So you will receive an e-ticket 2 days before the exam. So on May 9th, you will receive an e-ticket to your email. You will use that e-ticket to access your AP exam. You need to make sure that your device is plugged in and charged. It suggests that you use Chrome, so make sure that Chrome is working for you. We're going to practice logging on to the demo next weekend. So you'll have practice with the actual test interface before we begin the test. So next Saturday, we're going to, in the review session, log on to the demo, which won't have questions in it, but it'll basically be like a fake AP exam that we practice logging into and uploading. Okay, so that's what we're doing next weekend. So we're going to do that activity together. These other things you need to do by yourself. Okay, you have options as to how you can enter your data. I'm going to show you a quick video of that information in a second. You can use a Google Doc, Word document, or you can handwrite on paper. Either way is fine. You just have to have those materials ready to go before the test. So you need the browser, the Google Doc browser open before your exam begins. You need your paper, lined paper, pencil, calculator, your note card, that review sheets out and ready to go before the test begins. It is open notes, and we'll get to that a little bit more in a second. Basically, you review the security guidelines. Basically, don't cheat, okay? Super important that you don't cheat. You don't share your answers with anyone at all. We'll talk about the severity of that in a few minutes. Okay, so this is all before the exam. If you need extra time accommodations, you should have already dealt with that, but that doesn't apply to you. Okay, during the exam, it's very important that you do not refresh the browser or go back. Okay, on the actual exam, there is a timer, and it will give you a 5-minute warning when you need to upload. Okay, okay, after the exam, you can, up until June 20th, you can sign into your AP portal to receive your free score report. Okay, so let's watch a quick video about exam day, which again, all of these directions and information this is a vast overview. This is the short checklist I just showed you, and here's the quick tutorial video. So I'm going to show you this quick tutorial video about the day of the test, and then we'll talk about what materials you can and can't use. Okay, and this is all new to me. If you have any questions, please let me know.
And offer tips. 2 days before the exam, you will get an email with your AP ID and an e-ticket that will take you to your personalized exam. Check in 30 minutes before your exam starts. The first thing you'll do is enter your 8-character AP ID, and then fill out all your...
Sorry, I don't know if this is overkill here, but I just really want to make sure that we understand what we're doing. So 2 days before the exam, you'll receive an e-ticket to your email. That ticket, like if you were to enter a concert, you use that ticket to start the exam. So whatever device you open that ticket on is the device you'll be taking the exam on. So don't open the ticket on your phone if you want to use your computer to take the exam. If you want to use your computer to take the exam, you must open the ticket on your computer only. Okay, you're only allowed to open that ticket once. So it's very important that we understand that. Okay, so if you're going to take the test on your computer, you need to open the test ticket on your computer. It will take you to the
your AP ID and an e-ticket that will take you to your personalized exam.
So that's your exam.
Check in 30 minutes before your exam
You
starts.
enter your 8-digit code.
The first thing you'll do is enter your 8-character AP ID, and then fill out all your personal information,
which will take you 30
minutes.
minutes.
The timer at the bottom of the screen. Hit continue. The exam.
So even the check-in period, which is 30 minutes, will have a timer on the bottom. So you need to finish your check-in before the time for the exam, so before 12 o'clock. When 12 o'clock hits, you are basically using your exam time to fill out the introduction form, which is the opposite of what we want. So it's very important that we actually log in at 11:30.
Will automatically start when that countdown hits 0. And once it starts, the timer located at the bottom will count down how much time you have to read your question, craft your response, and submit it. If your exam has one question, you will have 50 minutes. If you have two questions, you will get 30 minutes for the first one and 20 minutes for the second one. If you are approved for extended time, it will be added automatically. The timer will turn red when you have 5 minutes left. That's when you should wrap up your work and start submitting your response. Once that timer hits 0, you will automatically be moved to the next question.
Okay, so that's also important. When that timer hits 5 or 4:34, you need to make sure that you're uploading your work because it could take you 4 minutes, 5 minutes to upload your work. If it times out before you upload, there's nothing that I can do to help you. You got no points for that first question. So it's super important that you submit your work when that 5-minute timer comes up. It's located on the bottom of your screen. Okay, so you need to be very careful. If you don't submit anything, you can't get any points.
This is important. You can get partial credit for a partial answer, but you will not get any credit if you submit nothing. You can use any device to take this exam, a desktop, laptop, tablet, or phone. If you're typing on a desktop or laptop, you can reduce the size of your browser window so you can see the question and your text file side by side. Type your AP ID and initials at the top of the page. You can also write your responses on paper. If you're writing by hand, use a number 2 pencil or a pen with blue or black ink. Use white paper, lined or unlined, and write legibly. Print or cursive is fine. You can place your phone next to your paper so you can keep an eye on your time. Be sure you put your AP ID and initials at the top of the page. If you use more than one piece of paper, number each page in order. There are 3 ways to submit work. You can attach a text file typed in another application. You can paste a response typed in another application. Or you can attach photos of work you wrote by hand. Let's walk through each option. To attach a typed response, click Attach Response with Attach Text File. You can browse for a file. Once you hit Submit, you cannot go back to that question. So make sure you're ready to move on before you hit Submit. If you choose to copy and paste your work, click on Paste Response. Copy your response and paste it into the box. Review it to make sure it has everything you want to submit and is formatted correctly. Once you have checked the pasted copy, hit Submit. If you're attaching a handwritten response, tap Attach Response. Tap Attach a Photo. Make sure it is vertical and you are in a well-lit space. Snap your photo. If your response has more than one page, make sure you attach the pages in order. Remember, once you hit Submit, you cannot go back.
Okay, so that's important. If you're taking pictures, you must submit the pictures in order. So my suggestion is showing a phone here so that you don't have to pick up the phone to look at it, which takes time, scroll on the phone to check the time or to read the rest of the question, which also takes time. I suggest that you open the test on your Mac. And either if you're typing a response, you can split screen. So half the screen can be a Google Doc, the other half of the screen can be the test. You can type on the document, and your options are to either copy and paste from the document onto the AP exam or submit the file. For the paragraph, if there's a paragraph response or a planning response in which you have to plan a lab, you might want to type. Okay, it might be faster for you to type. But if you're writing out equations, right, it takes a long time to type equations. So if it's a question that involves equation manipulation, you're most likely going to want to do that on lined paper. You need to number the pages, put your initials on top and your AP ID on top. because we don't know what kinds of questions there are, you want to be ready for all three situations. Okay, or all two situations rather. So you're going to open this is my suggestion, okay? You can do it however you want. My suggestion would be to open the test on your Mac, have lined paper ready to go, already numbered, right? With your initials and ID written on top before 11:30, right? Have the pile of 5 pages numbered front and back, 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, however many pages you think you're going to need. Write your initials on top and your AP number. Have those papers ready to go in case you need them. Okay?
If you just have one question for your exam, that's it. You're done. For exams with 2 questions, if you finish the first one with time to spare, a timer will start a countdown for when your second question will automatically start. When you see this screen, the timer has started for your second question. The process for answering question number 2 is exactly the same as for question number 1, except you have 20 minutes to read the question, work on your response, and submit it. Once you submit your second answer, you're done. Some AP courses like World Languages and Music Theory will have exams that work a little differently. To learn more about these courses and more details on AP 2020 exams, go to cb.org/AP2020.
Okay, and that really vast, extensive document with a lot of detail is also linked. It's in the overview section. So if you want more in detail, that's linked in there too for you guys to easily access. All right, so it's important that we talk about, I know you guys are super intelligent, right? You're super driven and you're honest. So I probably don't need to worry about this, but I do want to stress to you the severity of cheating and plagiarism. So we're going to quickly watch a video about the rules, okay?
Here, we highlight the rules, including what open book, open notes means, what you can and can't do on the internet, and what we're doing to ensure fairness. The exams will be open book, open notes, so you can use resources from your class or teacher, such as your textbook, class notes, study guides, previous assignments, or previous exams. But you can't consult with anyone during the exam, including other test takers or family members. You can search the internet during your exam.
Okay, so we're going to stop there. You cannot communicate with anyone at all. So it's important that when you start your test, you're in a part of your house that no one is going to bother or interrupt you. We all have zero doubts about the power that AP College Board has, right? So they have security measures in place. It's very important that you do not talk to anyone at all during the exam, except to yourself, okay? You can verbalize what you're thinking. That's fine. You can read the question out loud. You cannot talk to anybody else, okay? You need to make sure that your parents, guardians, grandparents, younger, older siblings, your dog, your cat, okay, that all members understand that, okay? So you need to be completely alone while taking the exam. You cannot share information before or after with anyone else. Do not, if you type something on the Google document, do not share that with anyone. No one. Not me, not your best friend, not your grandmother. That cannot be shared with anyone. Okay, there will be consequences for that, meaning that they'll notify the high school, your respective college, your test won't be scored. Okay, there will be legal repercussions for that. Do not share your answer with anyone. And yes, they will find out. They will, okay? So do not risk it. So you can use the internet is the next thing they're gonna go into. I highly suggest that you don't. These are completely new questions. I have been studying the exam for 3 years now, and I still have no idea what they're going to put on it. So no one on the internet knows what's on the exam either. So do not waste your time Google searching the questions or trying to find help from the internet. Use every minute to get down as much information as you can to prove that you understand. Okay, and you will get partial credit for that. Do not waste your time on the internet.
But we strongly advise against it. The information won't be helpful for your responses, and searching will waste valuable time. You also can't use sites or apps like Reddit, Discord, or any social media platform to share information or collaborate with others during the exam. You can use digital docs such as Google Docs, but they must be private or downloaded to your computer to ensure no one else can see your work. All your work must be your own and will be reviewed using a variety of methods, including digital security tools to detect plagiarism. Your teacher will also have a chance to review your work and let us know if there are any inconsistencies. Any student who gains an unfair advantage will have their scores canceled, and the incident will be reported to their high school and college admissions offices. Just remember, the AP exam rules are designed to ensure you and all students can show colleges how much you've learned, and we can't wait to see that. For more details about the rules and test security, go to cb.org/AP2020 rules.
Okay, so summary, right? You can use anything you want on the test besides the internet and other people. So you can use your calculator, your note card, review documents, basically anything you want, old labs, right? One of the questions might be a lab-based question in which you have to design a lab. If you have your pile of labs, which might be at school, I'll work on that, trying to get those back for you. If your folder's at school, if you can send me an email, that'd be great. I'm gonna see if I can get back into school to get you those folders. Okay, you can have your materials out on your desk, ready to go, okay? But you can't use other people and you can't use the internet. Okay, so we're gonna start with the review of kinematics. So basically we know that kinematics is a study of how objects move. So basically we're describing how objects move. Okay, we talk about why they move in dynamics. There's two different types of variables in which we focus on in this unit, right? So the types we have two specific types. The first type of variables in which we discuss in kinematics are vectors, okay, which are basically variables that have magnitude and direction. And of course, units. So it's any variable in physics or quantity in physics that has magnitude and direction, as well as units. Okay, and an example would be velocity, which we'll talk a little bit more about in a few minutes. The other type of quantity that we look at are scalar quantities, which are variables with magnitude only, as well as units. Do you remember what magnitude means? So magnitude just means the value or number. Okay, so it's just a number with units. The direction does not affect the measurement of that description. Okay, so in kinematics, the way that we describe motion, the first way would be to describe an object's position. So the position, which we use the variable x to represent, is the location of an object measured from some reference point. Usually we get to determine that reference point, and we measure that reference point as the 0 mark, but sometimes it's given to us. Okay, feel free to stop me if I am going too fast or you have questions, okay?
Okay, cool.
Okay, so we can describe an object's position, okay, or we can describe an object's distance, which sometimes we also use x to represent, sometimes we use s to represent. Depends on the situation, unfortunately. But basically the distance is every step taken along a path, regardless of the direction, right? So every single step that you take is included in that measurement. There's no direction because distance is a scalar quantity. And the units that we use to measure it are meters. Okay, our next relationship in which we can describe how objects move is displacement. Okay, so displacement is the straight line distance from the starting to the ending positions or points. We use delta x, so change in position, as the variable. Displacement is independent of the path. So we don't consider the actual path of motion. We only examine the distance between where an object begins and where it ends its path. So we don't look at the actual path, but we do label the direction of that displacement because displacement is a vector quantity. So displacement can be positive, negative, or 0. And we're going to talk about situations to describe when it's which. So if an object begins and ends at the same position, it has 0 displacement. So if you start on a track at the starting line and you run an 800, right? You end up back at the starting line. So although you ran 800 meters, that would be your distance, your displacement would actually be 0, right? You start and end at the same position. So the difference between the initial and final positions is 0. Okay, displacement can be negative. This one's a little bit tricky, but if you think back to the Tumble Buggy Lab way back in September, an object can technically have negative displacement if it begins at a point that is below or to the left of the starting position. So if we choose a reference point, and then the object is moving either towards that reference point or to the left of it, it can have a negative displacement. Okay, and a positive displacement would be when the object moves away from the starting point or reference position in a positive direction. I'm going to add that. So if an object begins at the starting position and moves in a positive direction, the displacement is positive. So it can either move above the starting position or to the right. Okay, which we could also use north or east to label as well. And the units for displacement are meters. Okay, so next up, let's talk about distance and displacement and how we use those to measure rates of change. So when we're talking about the rate of change of displacement or distance, we talk about speed and velocity. So two more ways in which we can describe how an object is moving. We're going to start out with speed. So speed, which we use the variable v, or sometimes we use s to represent, is the total distance traveled over the total time. So it's the rate of change of the distance over a unit time. Basically, it describes how fast an object is moving without considering the direction. Right? The direction is basically ineffective or inefficient in the measurement. We don't actually take it into account because speed is a scalar quantity. An easy way to remember that: s in scalar, s in speed. The units we use to measure speed are meters per second. Unfortunately, sometimes books and tests will use the word speed when they mean velocity, so please be careful. Okay, if the speed is constant, then it means that the object will travel the same distance in each unit of time. So that means that every 2 seconds, it's going to travel the same distance. So 2 meters in every 2-second interval within that path of motion. So that means that the speed would be constant and there would be no acceleration. Okay, the vector way in which we measure rate of change of an object's location is velocity. So velocity is the displacement traveled over time, also referred to as the rate of change of displacement. It describes how fast and in what direction an object is moving. So velocity relies on the direction. So velocity can be positive or negative. It can be constant or changing, which we'll talk a little bit more about in a second. Velocity, again, is a vector. We can determine the direction of the velocity because it is always in the same direction that the object moves. So if the object's displacement is positive, its velocity is positive. If the velocity or the displacement is negative, the previous vector is also negative. Okay, so if displacement's negative, velocity is negative, and vice versa. Velocity can also be 0. So the velocity of an object is 0 if it's not moving. If there's no change in displacement, then the velocity is 0. Okay, a negative velocity indicates the object is moving in the negative direction, which means to the left or down. The units for velocity are meters per second. Okay, and velocity can also be constant. If velocity is constant, there's no acceleration. We'll get to that in a minute. It means that the same amount of displacement is covered in the same direction within a unit of time. So it's not just the same displacement, but also the same, also the same direction in the same amount of time. Okay, so let's break these apart a little bit. So with velocity, we have average velocity and instantaneous velocity, in addition to constant velocity. So let's take a look at some equations and specify what those vocab words mean. So I'm actually going to do this over here. Okay. So change in position, aka displacement, is the difference between the final and the initial positions, right? So we know that delta x equals v final minus, or x final minus x initial. So final minus the initial. Anytime we have delta or change in, it's final minus initial. When we're talking about average speed or average velocity, it's the average rate of motion over the entire trip. Okay, so if they're asking for average speed, we take the total distance and we divide by the total time. If we're asked for average velocity, or we're told that the velocity is constant, which means there's no acceleration, we can use change in position, delta x, over time. It is technically change in time, but about 90% of the time, the initial time is 0. So technically it'd be final time minus 0. Okay, but it could technically have a delta t in the denominator. Okay, change in velocity, just like change in position, change in speed or change in velocity is the difference between the final and the initial velocity. We use that relationship most when we're talking about momentum and impulse. So we use delta V most during that unit, but it does apply here. Okay, the other thing that we need to talk about is the difference between average and instantaneous velocity. Okay, so I'm actually going to move this to its own page. Okay, so when we say instantaneous velocity or speed, in the case of APC, we focus on the velocity portion. It means the speed or the velocity at a specific instant, so at an exact second or instant in the object's motion, rather than the entire path. So sometimes we're asked to look at this graphically, sometimes we're given equations, okay? So basically our relationships here, we're talking about instantaneous velocity. Velocity is equal to the instantaneous velocity is equal to the rate of change of position over time. So it's dx dt. So we take the derivative of the position function in respect to time to find our instantaneous velocity. Okay, so instantaneous velocity is the rate of change of position in respect to time. We also can find instantaneous acceleration, which sometimes ends up being constant, but if we take the derivative of the velocity function in respect to time, we can find the acceleration at that instant. So a shortcut thing to remember, right? If you want to go from position to velocity, so if we want to go from position to velocity, we take the derivative. If you want to go from velocity to acceleration, we take the derivative of the velocity function to get acceleration. If we want to go in the opposite order, so we have an acceleration function or value and we want the velocity function, we integrate. So to go down the row, we derive. To go up the row, we integrate. So if we're given a function, f of x, which would really be, technically it'd be either x sub t, v sub t, or a sub t. We can either derive or integrate. If we're given graphs, we can either take the slope of a velocity, position versus time graph to get our velocity. We can take the slope of a velocity versus time graph to get our acceleration. If we want to go in the opposite order, right, if we have an acceleration graph, we can take the area underneath the curve to get the velocity. If we're given a velocity versus time graph and we want the displacement during 2 time intervals, we can take the area to find that displacement. That's going to take too long. I'll get back to that. Okay, any questions there so far? Okay, so that will also be added to our document. So those are instantaneous values. Last thing we have to talk about within kinematics is acceleration. Okay, so we know we can have instantaneous acceleration, constant acceleration, or average acceleration. We almost never are asked to find the average acceleration on the AP exam. So we're not really going to spend much time talking about that. We know that acceleration, we use a lowercase variable a, right? It's a change in the velocity over the change in time, also called the rate of change of velocity. Okay, so we can accelerate in 3 ways. Okay, we can either speed up, slow down, or change our direction. So we can only accelerate if there is a change in the magnitude or the direction of the velocity. Because acceleration relies on velocity, and velocity is a vector, acceleration is a vector. The direction of the acceleration, we use either a positive or a negative sign to denote. And depending on the system that we're looking at, we use different sets of rules to figure out what would be positive or negative. But ultimately, we assign which way is positive or negative unless it's assigned for us. So let's talk about situations in which we are speeding up or slowing down, and then when acceleration is constant. So units for acceleration are meters per second, or meters per second squared. So for example, if an object has an acceleration of 5 meters per second squared, that means that every second the velocity will increase by 5 meters per second. If instead our acceleration was negative 5 meters per second squared, then every second the velocity would decrease by 5 meters per second. So I'm just going to talk about, using this chart as an example, what acceleration means. Okay, so this exam is now mostly conceptual, so it's important that we really do understand and can articulate what the difference between these variables are. So let's say we're looking at this object's motion over a 4-second interval. The acceleration is a constant 5 meters per second squared. What that means is that every second the object's velocity increases by 5 meters per second. So at time 0, its velocity is 0 because it hasn't had time for the magnitude of the velocity to change yet. 1 second later, velocity is 5. 2 seconds later, velocity would be 10. 3 seconds later, velocity is 15. 4 seconds later, the velocity is 20 meters per second. Right? Each second that the object moves, its velocity will increase by 5 additional meters per second. Okay, and if the velocity changes at constant intervals over constant time periods, then we say that the acceleration is constant. Okay, so I'm just going to keep going unless we ask questions or tell me to stop, okay? Acceleration, again, is a vector, so it can be positive, negative, or 0. The acceleration of an object can be 0, and an object can still be moving, okay? So just because acceleration is 0 doesn't mean the object's not moving. Acceleration is 0 when the object is either not moving or it's moving with constant velocity, right? So if there's no change in the velocity, there's no acceleration. And remember that an object can be moving with constant velocity and then accelerate, and vice versa. So determining when acceleration is positive or negative, okay? So first we'll talk about when it's slowing down or speeding up, and then we'll talk about how we know if acceleration is positive or negative. So acceleration can be negative if acceleration points in the negative direction. So if the vector is negative, the acceleration is negative, okay? But we can have negative acceleration and both be speeding up or slowing down. So in our first situation here, we see a box on a frictionless incline, or frictionless surface rather. Velocity is in the positive direction and acceleration's in the negative direction. So velocity and acceleration vectors are in opposite directions. So the object is slowing down, but it's moving in the positive direction. So it's slowing down in the positive direction. What that means is that the net force acting on the object is in the negative direction. So our free body diagram most likely looks like this, right? We have force of friction to the left. We could have no force acting to the right, but it can still be moving to the right. But because the net force is in the negative x direction, the acceleration will be negative. So it's still moving in the positive direction, but it's slowing down because the net force is in the negative direction, meaning acceleration is negative. Okay? If both velocity and acceleration point in the negative direction, then the object is moving in the negative direction, but it's speeding up. Okay, so acceleration can be negative, and the object can still speed up, as long as velocity and acceleration are in the same direction. So that free body diagram would most likely look something like this, right? We have normal force, force of gravity, and an applied force, or maybe a tension that points to the left. Okay. Other piece of information that's a review from a very, very long time ago, way back in September, is when to determine if an object's speeding up or slowing down. So in order to figure that out, we need to know both the direction of the velocity and the acceleration vectors. If a velocity and acceleration are pointing in the same direction, then the object speeds up. So if acceleration and velocity are both positive, it's speeding up in the positive direction. So the picture to the right here, right, we're speeding up in the positive direction. The picture on the left here is we're speeding up in the negative direction. slowing down, right? If an object slows down, that means that the vectors are pointing in opposite directions. So if velocity is negative and acceleration is positive, we are slowing down. Okay, if velocity is positive and acceleration is negative, we are slowing down. Questions so far?
Like, how would you know, like, what direction they would be going? Is it, like, whatever one is greater?
Isn't it positive and negative?
Velocity vector. The velocity vector determines the direction of the position, right?
Okay.
So if, I'm going to type that on here, actually. Actually, that was fine. Look to velocity vector for direction of motion. So velocity here is positive, so we're moving in the positive direction, but we're slowing down. Velocity over here is, let me see if I can do this. There we go. Velocity over here is negative, so we're still slowing down because they have opposite signs, but we're slowing down in the negative direction. So the direction of the velocity determines the direction of the displacement. We get the direction of the acceleration from the free body diagram. If velocity and acceleration have the same sign, then the object speeds up. If the acceleration and the velocity have opposite signs, then the system or object slows down.
Okay.
Good question. Okay, so how are we doing?
Good.
Okay, so we can figure out when velocity, acceleration, opposite directions, when it speeds up, slows down. We can find when acceleration is negative versus positive, right? We determine that. Direction of acceleration really does come from the free body diagram, which now we understand, but when we first were learning this, we didn't know that yet. Now we're going to talk about when the acceleration is constant. Okay, so acceleration due to gravity, which we call, is an example, a special specific case of constant acceleration. It's the most common case that's presented to you in physics in general, because everything that we do is located on our planet, right? And our planet causes objects to move at constant velocity due to its gravitational field. So all objects that fall near Earth's surface undergo the same acceleration in the absence of air resistance. So if there's no drag force, if they don't give you F sub D equals negative kV or negative BV, if they don't give you that, then there's no air resistance. Okay, so if it doesn't specifically say that there's air resistance, you assume that there is none. If I could strike this through. Forget how. Let's try this. Oh, no. Oh, I'm just going to leave it for now. Okay, so G, all objects accelerate at a constant rate of 9.8 meters per second squared. On the AP exam, they tell you to use 10. So they tell you to forgo the actual variable and its significance and use 10 on the AP exam. Okay, and that will make your calculations a little bit easier. So we can actually have the force of gravity affect objects in 1 or 2 dimensions, right? If it's affecting the object in 1 dimension, we call it free fall. If it affects it in 2 dimensions, we call it projectile motion. So let's talk about dimension 1 first. So types of free fall. We categorize them by 3 types. So type 1 is when an object is dropped from rest. I call it type 1 because that's the easiest type. That means that the initial velocity is equal to 0. And for acceleration, we use a positive 9.8. On the AP exam, you're going to use 10. Positive 10 meters per second squared. And remember that positive, we assign that to be down in the direction of the force of gravity. Right, and that's 1 dimension, so we use the big 4. The second type is when an object is thrown vertically downward. In that case, our initial velocity is greater than 0. And we still use a positive 10 meters per second squared for the acceleration. So initial velocity is positive because it means down. And acceleration is down. If it's thrown vertically upward, our initial velocity is technically negative for up. That means that it's less than 0. And the acceleration would be negative because it first moves up and then comes down, right? So it opposes the force of gravity for the majority of its path. So we use a negative value for A when we're solving. It algebraically works out best if negative means up. Okay, questions there? So we're talking about any constant acceleration in 1 dimension, specifically for free fall. We use the big 4 equations, which are listed here. V equals V naught plus AT. They are different on the AP exam study guide or formula sheet, but it's open note test this year, so you can actually use your note card. So you don't have to worry about using their version of the equation. So here are our big 4 equations. Okay. So let's talk about constant acceleration in 2 dimensions. And then we'll go into, we'll talk about interpreting the word problems first, and then constant acceleration in 2 dimensions. So it's very important that we read questions carefully. So interpreting word problems, I'm just going to make a little key here. So if it states in the problem, the object starts at rest, falls, is dropped, okay? Or it doesn't specifically give you a velocity, V naught is 0. Okay, so these are some assumptions that we have to make. If it states in the problem, the object comes to rest or stop. Okay, that means that the final velocity is 0. Specifically, super important that we remember that the final velocity of a falling object just before it hits the ground is not 0. The final velocity we can never assume is 0 unless it specifically says that the object hits the ground and comes to rest. Okay, if it doesn't say comes to a stop, comes to rest, you can't assume it's 0. You see the word constant velocity Object moves with constant velocity. Acceleration is 0. Anytime we see the word free fall, launched at an angle, launched horizontally, and it doesn't give you a planet, and it doesn't tell you anything about air resistance or drag, you assume that g is 10 meters per second squared. Okay, so those are good assumptions that we need to be able to automatically make. And that's why. Okay. All right, so now we're going to talk about constant acceleration in 2 dimensions, projectile motion. There are x and y components that are important. In projectile motion, we specifically concentrate on 2 types. We have horizontal launch, which means that the object is launched with the horizontal, usually off a table or some other flat surface. The assumptions that we make when we're talking about horizontal launch, we assume that the initial velocity in the y is equal to 0. The initial velocity in the x, oh boy, why do I keep doing that? Is a constant value, and it's either given to us or we have to find it. Okay, we also know that acceleration in the x, if there's no air resistance, is always 0. The acceleration in the y, we're talking about horizontal launch, it begins at its maximum height and moves only downward. So the acceleration is 9.8 meters per second squared. I'm just going to add that to the definition here. So it's launched with the horizontal and begins at the maximum height. We know that at the maximum height that the y component of velocity is 0. So those are the assumptions that we make. In order to solve these problems, right, basically our general idea, the first thing we need to do is find time. We find time first because primarily it's the only variable that we can use in both the x and the y direction. We usually take advantage of our y variables to do so. So we have sorry, that's not a delta. Go up here and copy the delta really quick. So you have delta y. Ooh, that didn't work. Equals the initial velocity in the y, which in this case is 0. Times the time. plus 1/2 a times t squared. Okay, and we solve for t. Once we have time, we can then use time to find the range, which we manipulate only the x variables. We have delta x equals VO in the x. And you can obviously use your cheat sheet or this review sheet on your AP exam. So delta x equals VOx times t. That equation is plus 1/2 at squared, but there is no acceleration in the x. So acceleration in the x is 0. That whole section of the equation cancels out. For some reason in this class, we are extremely bright and talented and amaze me most of the time, but some of us forget this, so that's why I'm writing it in here instead of just deleting this. So this whole thing does cancel out, but the reason why it cancels out is because there's no x component to the acceleration. Is there a strike through option? There should be.
I think it's under format and then text. It's like shift through.
Oh, Command Shift X. Okay, thank you. I'm gonna do that here too. Command Shift X. There we go. Okay, so there is no initial velocity in the y. We're talking about horizontal launch, and there is no acceleration in the x. Last thing that we do would be to find maximum height. We could do that. Okay, and this delta y would be our delta y max, which would be our max height, which would basically just be delta y in this case. Okay, so we have about 4 minutes left. I'm going to continue. Okay, so last thing here, you can find the final velocity, which you might need for questions that ask you about energy. The final velocity in the y, we can use this equation in terms of y variables. We know initial velocity in the y is 0. We're usually given delta y, so we don't need to find it. We know acceleration in the y is positive, and we can find the y component of the final velocity. The x component of the final velocity is the x component of the initial velocity because there's no acceleration in the x. To find the magnitude, right, you do Pythagorean theorem. Note also, right, these equations can be used if you have time and you need delta y, you can use this equation. If you have range and time and you need initial velocity in the x, you could use that equation. Okay, so this is the general sets of equations that you can use to solve for information in horizontal launch, but you don't exactly have to follow them in this order in this step. Okay, so next we're going to talk about non-horizontal launch and the set of equations that you can use. Okay, so non-horizontal launch is our next type of projectile motion. Non-horizontal launch is when the object is launched at an angle with the horizontal. So there are two components to each of the kinematic variables. So displacement, velocity, and acceleration. So use the big four in terms of x or y. So assumptions that are true no matter what, the acceleration in the x is 0, the acceleration in the y is technically for non-horizontal launch negative, because first we go up, we oppose the direction of the force of gravity. So it's negative 10 meters per second squared. Because it's launched at an angle with the horizontal, there are x and y components to the initial velocity. To find the x and the y components, we take the vector and we multiply the magnitude by cosine to get the x component, VO sub x. We multiply the vector times sine to get the y component. If we don't know the initial velocity, we skip that step and head to the next step. And we can use that next equation to find VO and the y. And then the third step to find VO and the x if we're not given velocity. If we are given velocity, we calculate the x and y components, and then we find time. So we use the height equation, delta y equals VO y times t plus 1/2 a in the y times t squared. Always question, right? It makes it easier if the object starts and lands at the same height. If it does start and land at the same height, then the delta y value is 0, and this equation becomes easy to solve. If the object does not start and end at the same height, plug it into your calculator and use solver, right? Don't spend your time doing the quadratic equation. Make sure you know in your calculator how you could quickly solve that quadratic in a matter of seconds, okay? If you need help with that, let me know. So we can find time, range, maximum height using the following equations. Last thing we need to talk about is interpreting graphs. Okay, so graphing constant acceleration. Let's say that we drop a tennis ball from a height of 2 meters. We know the acceleration is negative 9.8 meters per second squared, and that the initial velocity will be 0 because we're dropping it from rest. So technically, our position versus time graph is going to be a parabolic curve. Okay, it's going to be concave down, which basically means here, right, that we're starting at a position of 2 meters, and the slope of this first segment here would be 0, but over time, the slope is going to increase. Remember that the slope is the velocity, so as we isolate segments, aka we draw tangent lines, and we take the slopes of those tangent lines, the slopes of those tangent lines are going to gradually increase until the object reaches a position of 0. Okay, so we're concave down, the velocity is going to increase in magnitude, right? It's going to increase in magnitude. The direction is negative, so that's why our shape here is concave down. But it is an increase in the velocity, just in the negative direction. So that leads us to our velocity versus time graph, right? If we take the slopes of these tangent lines and then we plot those, we will get a linear line. We know that the velocity is going to start at 0 and gradually increase in the negative direction as time increases. So again, we have a straight line with the form y equals mx plus b. The y-intercept is 0. And the slope, right, the slope should be the acceleration. So it should be negative 9.8 or negative 10 if we use the value given to us by College Board. The last graph and the easiest graph would be the acceleration graph. right? We know acceleration is constant. So that graph's going to give us a linear, flat, horizontal line at negative 10 meters per second squared. Right, again, that's negative due to the downward direction. So it's easiest if you memorize, right, what the shapes of these graphs should look like. It'll help you to be able to understand quickly what the graph should look like. You may be asked to plot graphs in the examples that I posted in the minutes from today, right? The second question involves graphing, position versus time, velocity versus time, and acceleration versus time. Okay, so that's a complete review of kinematics, all the concepts and information. I suggest that you try these two problems out and then check out the answer keys. And I will see you next week for continuation of the review.